The Kubernetes service binding specs is a new way of connecting a backing service with an application. Currently, when you deploy an application and you want to connect it to a database, you face the challenge of correctly mounting the secret for the database. This becomes even more complex when you switch from one database to another. For example, you have a to-do app with a MySQL database. You notice that MySQL doesn't have all the features you need, and therefore you switch to a Postgres database instead. Should be rather easy, right? Wrong. If you simply switch out the chart and connect to the database, you will find yourself in the situation we were in. You have to manually reconfigure your secrets and mounting points to correctly mount the database secret. In reality, you don't know how a database formats the secret, how they're named, and how they will be stored. The solution? The Service Binding Specification for Kubernetes. The Service Binding Specification defines a standardized way to connect a service to a workload, without worrying too much about how that service handles its secret. In this example, we will be using the Red Hat Service Binding operator for OpenShift. So, how is it done? The simplest approach is to add an annotation to the service and create a service binding custom resource. For example, your MySQL database automatically creates a secret. You can add an annotation referencing that secret to the deployment. In this case, the secret has the same name as the database. And now we create our service binding. So, what are we doing here? We define two things: our application and our service. The application usually has some business logic and needs the service to function. The services define the part we want to connect to, in this case, our database. Notable features are the bind as file, namespace, and naming strategy fields. Bind as file tells a service binding if it should mount a secret or inject it into the environment variables. The namespace field declares in which namespace our service is. To avoid the challenge of referring to secrets from another namespace, the operator copies the secret into the namespaces where they are needed. Naming strategy defines how the environment variables should be named. Default is kind_name. This results in database_password. If you change the naming strategy to none, the resulting name will just be password. Additionally, there's an optional mapping field. Here you can change the secret field's names entirely. This is useful if your application expects, for example, database password, but the provided secret name is already Postgres database password. But you can go even further with the annotations. Not only can you define where the secret is, but what its fields are going to be called on pickup. This further simplifies the process of mapping secret entries. However, what if you don't have one deployment, but several microservices that need a database connection? There is a solution for this as well, the label selector. Rather straightforward, and it should be familiar to most people who've used Kubernetes before. Basically, each pod matching these labels will get the secrets delivered. But let's talk about the service binding specifications for Kubernetes themselves. As we mentioned before, they want to standardize how to connect applications with the services they need. A few operators providing custom resources in OpenShift already implement the specs out of the box, so you don't even have to put any annotations on the deployments there. However, adoption of the specifications has not spread out very much yet, so either using annotations or directly referencing the secret in the service binding resource at worst will be a much more common use case, for a while at least. What we haven't even talked about is that the applications consuming the secret are also included in the specs. Basically, they're supposed to process their connection information from the same place in the same format every time. This is perhaps less important, however, since the way the secrets get delivered can be fine-tuned so much in the service binding. Overall, the service binding implementation we looked at was very interesting due to its ease of use and how it decouples services and applications. We already have concrete ideas of where we are going to use it on our own clusters. For the future, we hope to see the specifications get adopted more widely to make the life of application developers, service providers, and cluster operators easier. Thanks for watching.